A very good evening to all of you. I hope आप सब बढ़िया एकदम मस्त एकदम ढिंचाक. Yes, good evening everyone. I hope I'm audible and visible. I am here back again with another session of B2A series where we are targeting NSEJS 2025. So इस series में हम कर रहे हैं NSEJS crack करने के लिए वो सारी preparation which is required. We have been covering topics which are really very important for Junior Science Olympiad. So I hope I'm audible and visible. Let me know if I'm audible and visible, guys. Yo. Let me know, guys. I hope everything is fine. Am I audible, visible? Great, good going, good going, good going. So B2A series, your very own B2 series for NSEJS 2025, right? So I hope you have already subscribed our new channel, which is specially for science lovers, science Olympiad aspirants, that is Vedantu Science Olympiad. If you haven't subscribed it yet, make sure that you subscribe the channel because very soon we'll be shifting our this B2A series on this Vedantu Science Olympiad channel, right? So the series will keep on going, guys. This B2A series, basics to advanced series, but the series will soon be going on this channel, Vedantu Science Olympiad channel, because this series is about Junior Science Olympiad and Science Olympiad. Yes. Hi, Digaj Motivational. Okay, good evening, good evening. Let's see what we are going to study today. In the last session of the series, we learned quantum numbers. I hope you remember N, L, M and S. 4 quantum numbers which gives you the entire address of an electron, right? Shell, subshell, orbital, and of course the spin. Now in today's lecture, we'll learn how to use these quantum numbers to write the electronic configuration. Yes. Okay. Great. So I hope I'm audible, visible, loud and clear to everyone. Yo, NLMS. Perfectly fine, guys. So what is electronic configuration? So basically how the electrons are distributed in an atom, the various shells, subshell and orbitals, that is the electronic configuration, the arrangement of electrons inside an atom, right? So for that, first thing that you are required to know is the atomic number. I hope everyone is aware with the atomic numbers. Got it, guys? Yes. So in our childhood, I will say class 8th or 9th or 10th, in fact, we write this electronic configuration as 288, right? This is our school curriculum. But I am going to tell you what this 888 means and how we can express this 888 in terms of SPDF, right? So let's first learn the rules. There are certain rules, right? So every game has a rule, guys. So if you want to play cricket, you should know the rules. If you want to play football, you should know the rules. If you are going to appear in an exam, you should follow the rules, right? Same, if you want to set electrons inside an atom, you should know the electronic configuration. And to write the electronic configuration, you should know the rules behind, right? Yes. Okay, great. So we have three main rules to know for electronic configuration. The first is Aufbau rule, and then we have Hund's rule of maximum multiplicity, and the third rule is Pauli's exclusion principle, right? So guys, I am going to tell you all of these three rules first, then we'll write the electronic configuration. Hi Digaj Motivational, very good, good going, that's good. Yes, okay, so first rule, that is Aufbau rule, also known as N plus L rule. So Aufbau rule, Bohr-Bari rule, or N plus L rule, we can call it N plus L rule. We can also call it Bohr-Bari rule, right? So we can also call it Bohr-Bari rule. Bohr-Bari is the name of the scientist, and why N plus L, I am going to tell you very soon. So according to this rule, the orbital which is having lower energy, that will be filled first with the electrons, right? And if it is completely filled, then we'll move on to the next orbital having more energy, right? So the electrons are being filled in an atom in the increasing order of energy of the orbitals. So first the electrons will go to that orbital which has lower in energy. The low energy orbital will have the electrons first. Once it is filled, then we'll move on to the next orbital having energy more than that orbital. Now, how to decide which orbital has less energy, which orbital has more energy? That is why we have this n plus L, right? So, n is principal quantum number, L is azimuthal quantum number, right? So, lower is the n plus L value. If n plus L value is less, that means energy is less. If n plus L value for an orbital is more, that means the energy is more. So how we can decide the energy order of the various orbitals? By looking at n plus L value, right? Yes. Digraj bache, this is purely English series, right? So that is why I am taking the entire lecture in English. तो बच्चे अगर तुम्हें कुछ भी कांटेक्ट करना, इफ यू वांट टू नो एनीथिंग यू कैन कांटेक्ट मी ऑन द टेलीग्राम. टेलीग्राम पे दिग्गज मोटिवेशनल यू कैन कांटेक्ट. चलो, सो n प्लस एल रूल जानते हैं. फॉर एग्जाम्पल मेरे पास है 1s, right? I have 1s, I have 2s, I have 2p, I have 3s. These are the orbitals I told you in the last class. First shell has s subshell, second shell has s and p subshell, third shell has s, p and d subshell, fourth has s, p, d and f, right? I told you this very much clearly in the last class. Very clearly I have told you this, right? So now let's check the value of n plus L in each of these cases. What is n? The shell number, the principal quantum number. The n for this is 1, first shell, and for s subshell L value is 0. That means for this the n plus L value is 1. Now n value is 2, and for s subshell L is 0. This is 2. Now n value is 2, for p subshell L value is 1, so it is 3. Now 3s, 3 plus 0, again it is 3. So the orbital which has the lowest n plus L value has the lowest energy, and the electrons will be filled in this orbital first. One, it is filled, this subshell is filled, then we can move on to the next subshell, right? And I hope you also know, in the last class I have told you clearly, s subshell has 1 orbital, right? P subshell has 3 orbitals, right? And again s has 1, d has 5 orbitals, and f has 7 orbitals. Can you please quickly tell me how many electrons I can fill in one orbital maximum? Maximum how many electrons we can fill in an orbital? Anonymous, no, you can't give, bache. You were eligible last 2 years, but this year you are not eligible for NSEJS anonymous person. And Ayush. Yes, guys. Okay, right. So maximum we can fill 2 electrons, right? Yes. Perfect. So this Bohr-Bury rule or n plus L rule says the electrons are added progressively to the various orbital in the order of their increasing energy, starting with the lowest energy. Of course, once that subshell is completely filled with electrons, then we move on to the next orbital. Got it, guys? Perfecto? Yes. Suppose 2 orbital has same value of n plus L. For example, I just told you the example of 2p and 3s, right? For both of them, n plus L value is same. 2 plus 1, that is 3. 3 plus 0, that is also 3. So in this case, how do we decide which has lower energy? Because both of them have same value of n plus L. Now in such cases, the one with the lower value of n, here n is 2, here n, shell number is 3, principal quantum number is 3. So the one with lower value of n will have lower energy. Got it? So both of them have same n plus L value. Out of these two, the one, that is 2p, because it has lower value of n, shell is less, that has lower energy. So we'll fill the electron in 2p first, followed by 3s. Got it, guys? Yes. So this is n plus L rule, Bohr-Bury rule, right? So these are the orbitals, these are their n values, these are their L values, and these are their n plus L values. So we will arrange all the shells in the subshell according to increasing n plus L value, so that we can have an order in which we can fill the electrons. Yeps, got it? Yes. So on the basis of n plus L value, So you know 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5s, 6s, 6p, 6d and so on. So guys, a very simple basic way to learn. Write them as such and then move like this. 1. So I will write 1s, then move like this. 2s, upward to downward. Then 2p, 3s, 3p, 4s, 3d, 4p, 5s, right? Then see 4d, 5p, 6, 4d, 5p, 6s, and then again move downwards. 4f, 5d, 6p, and then move downwards. 5f, 6d, and so on. You can write the order, right? Just move upward to downward. Follow the arrows. Got it? So just learn it. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s. At least 6s tak or 4f tak you can learn. Right? So learn it. And how I write this order? On the basis of n plus L value. The one with lower n plus L value is written first, has lower energy, will be filled with electrons first, right? We'll see how to fill the electrons later on, right? The one with more energy is written afterwards because it has more energy, more n plus L value. Got it, guys? Yo? Yups. So guys, 1s, 2s, 2p, learn it. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s. Right, guys, got it? Yo, perfecto. Yes. So I'm giving you time quickly. If you can remember, learn the configuration, guys. 1s, 2s, 2p, 3s. Because this is what we are required to fill the electrons to write the configuration. Yo, guys, learnt? 1s, 2s. So all the shells, S subshell. So we have one orbital in S subshell, guys. Any shell, the S subshell will have, I hope you remember, oh, what is happening? Any orbital, the S subshell, right? Any orbital. S subshell like 1s, 2s, 3s, 4s, they all have one orbital. Any shell P subshell has 3 orbitals. Any shell with the D subshell has 5 orbitals. F will have 7 orbitals, and in each orbital 1, 2, 3, 4, 5, 6. And in each orbital we can maximum fill 2 electrons, guys. Got it? Yeps. Yes, of course. Santosh, not exactly the classical mechanics you need to understand for quantum mechanics, right? But yes, like the laws of quantum mechanics, when they apply on macroscopic world, they yield the same, results as classical mechanics. That is the beauty of, quantum mechanics, right? Okay, guys. So we have S, we have P, we have D, we have F, right? Learned 1s, 2s, 2p, learned, guys. So how did I write this? According to Aufbau rule. And let me tell you, guys, many times questions have been asked on this. Which has more energy? Which orbital has more energy? Decide the order of energy. Just need to apply n plus L rule, right? In JEE Mains, in NEET, in Chemistry Olympiad, in Junior Science Olympiad, the questions have been asked on the same. You have to decide the energy order of the various shells. I'm going to show you the questions also, right? Okay. So let's move ahead. Okay, next rule is, right? I hope this is clear, guys. The order in which the electrons are being filled. Now, the next rule is Hund's rule of maximum multiplicity. Now, what does it say? As I told you, for example, I have P subshell. Now, my P subshell has 3 orbitals, and these 3 orbitals are degenerate. What do you mean by degenerate? Degenerate orbital means having the same energy. So, they are degenerate orbital. That means they have same energy, right? So, these orbitals have same energy, right? So, if I am filling electrons in degenerate orbitals, the one having same energy, then according to Hund's rule, I am supposed to fill one electron in each, and then the pairing will take place. As I told you, in one orbital I can fill maximum 2 electrons. So now if I am filling electrons, suppose I have 3 electrons and I am supposed to fill in these p orbitals, p subshell, right? So what I'll do? 1, 2, 3. I will do like this. First I will give each of them one electron, because they all 3 has same energy, right? They have same energy. And if I have to fill 4 electrons, 1, 2, 3, and then pairing will take place then. So how do I show electrons in an orbital? This is my orbital. I can fill maximum 2 electrons, 1 spin up, 1 spin down, right? So maximum I can fill 2 electrons. So suppose there are 2 ways. I have to fill 3 electrons. One is this according to Hund's rule. Another way is, suppose I fill like this, 1, 2, 3. Now let's check the spin. Here plus half, plus half, plus half, because all are spin up. Plus half, plus half, plus half. Spin quantum number. So the total spin here is plus 3 by 2, right? Now the here, this is plus half, but this is minus half. Down, 0, and this is plus half. So here the total spin is coming out to be plus half. Which is correct? This is correct, because it has maximum spin. This is why we call it Hund's rule of maximum multiplicity, maximum spin multiplicity, right? So as per this rule, if you are filling the electrons in the degenerate orbitals, that means the orbitals belonging to the same subshell having the same energy, that orbital, the orbitals are being singly filled first, then the pairing of electron will take place. Got it, guys? Yes. Perfecto. So this is Hund's rule of maximum multiplicity. So in a subshell, electrons never pair until no available empty degenerate orbital is left. Electrons do not start to pair up in a subshell until all the orbitals have at least 1 electron. So we are talking about those orbitals which have same energy. We call them degenerate, right? All the singly occupied orbitals will have electron with parallel spin. All the spin should be Khopdi up or Khopdi down, the parallel spin, right? Singly filled. Electrons do not pair until all the orbitals are filled. Got it, guys? So this is the Hund's rule of maximum multiplicity. Second rule, right? Yes, you can see here, guys. 1s2 we fill first, then 2s we fill, then 2p. And 2p 3 electrons, 1, 2, 3. This way we fill. This is the correct way of filling the electrons. And this is the incorrect, because in p subshell, all these 3 will have same energy. So each of them will be filled with single electron first, and then pairing will take place. Yes, Aditri, just do the whatever is there in class 11th, right? Because quantum mechanics is very tough nut to crack. Indeed, very interesting topic. Quantum mechanics, full of maths, right? Higher order mathematical skills are required to understand the beauty of quantum mechanics. But yes, it is an interesting topic. And for you guys, you should, start the exposure of quantum mechanics by exposing yourself to quantum mechanical model. That's all I can advise you right now, right? Okay, guys. So now the last rule, Pauli's exclusion principle says no 2 electrons can have the same value of all the 4 quantum numbers in an atom. No 2 electrons in an atom can have same value for all the 4 quantum numbers, right? That means all the 4 quantum numbers, principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. For 2 electrons belonging to the same atom, all these numbers cannot be same, right? For example, suppose I have 2 electrons in the same orbital, right? I have 2 electrons in the same orbital. So they belong to the same shell, N is same. They belong to the same subshell, right? They belong to the same orbital. So M is also same. But first 3 can be same because same shell, same subshell, same orbital. But what will be different? Spin quantum number. If one is plus half, another spin quantum number is, for this electron it will be minus half, right? Yes, It's just that you and your sibling, you have both have same address, same what? City, same locality, same house number, but you both of how we can distinguish between the two? You and your sibling, you have different names, different face and everything, right? So city can be same, locality can be same, house number can be same, but the face and the name cannot be same. So there has to be some distinction factor between the two, right? So no two electrons in an atom can have same values for all the 4 quantum number. NLM can be same for 2 electrons but not the S. Got it, guys? Yes. So this is the Pauli's exclusion principle. Right. Now I told you the 3 principles on which we are going to learn how to write the electronic configuration. First is Aufbau rule, which gives us the order of energy filling, right? Second is Hund's rule of maximum multiplicity, and the third is Pauli's exclusion principle. Now I am going to tell you how to write the configuration using these 3 rules. Okay, let me start with nitrogen, right? So nitrogen, I hope you all know atomic number is 7. That means nitrogen atom has 7 electrons. Now how these 7 electrons are arranged? So 1s, then we have 2s, then 2p. I told you the order you should remember on the basis of Aufbau rule. So we will first do 1s, then followed by 2s and then 2p, right? How many electrons? 7. 1, 2. Now it is completely filled. The low energy will be filled with electron first, completely filled. Next, 3, 4. Now this is also filled. Now move on to the next. 5, 6, 7. See, I am following the Hund's rule here because all these 3 belong to the same 2p subshell. They all have same energy. So according to Hund's rule, I will fill them with single electron first. Got it, guys? Yes, good, Sarita. So 1s2, 2s2. This power shows the number of electrons filled. 3p or 2p, 3. So the configuration of nitrogen is 1s2, 2s2, 2p3. This power shows how many electrons are there. So in Bachpan way, in the first shell I have 2 electrons. So first shell has 2 electrons. This is second shell. This is also second shell. So total 2 plus 3, I have 5 electrons. So 2, 5. K shell has 2 electron, L shell has 5 electron. This is how we write in Bachpan in class 9th. But exactly it is like this. 1s2, 2s2, because shells are also further divided into subshells. Subshells are further divided into orbitals, right? So let me take another example. Suppose I have sodium. Sodium has atomic number 11, right? So that means I need to fill 11 electrons. Again, let me write, guys. I have 1s and then we have 2s and then we have 2p, then 3s if we'll require, we'll do. S orbital, subshell has 1 orbital. P has 3 orbitals. S has 1 orbital. Got it? Now how to fill electrons in them? Same. First fill the one with the lowest energy, that is 1s. 2 electrons it can have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Have you seen the way I filled using Hund's rule? First I give them 1 electron each and then pairing, right? So I am supposed to fill total 11 electron in sodium atom. This is how I do it. 1s2, 1s2, 2s has 2 electron, 2p has 6 electron, 3s has 1 electron. So how I can write this configuration? So I will write the configuration of sodium is 1s2, 2s2, 2p6, 3s1. So in first shell it has 2 electron, in second shell it has 8 electron, in third shell it has 1 electron. 2, 8, 1. Got it, guys? Yo or no? Yes, have you got it? Now let me write the configuration of sulfur. Sulfur, the atomic number of sulfur is 16, right? That means 16 electron in sulfur we have. Let's write 1s, 2s, 2p, 3s, 3s. After 3s, we need to know the order 3p. So in s, I have 1 orbital. In p, I have 3. All these are degenerate. S1 and p again 3. How many electrons I am supposed to fill? 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So this way I filled the electron. So it is 1s2, 2s2, 2p6, 3s2, 3p4. This is the configuration. Got it, guys? 1s2, 2s2, 2p6, 3s2, 3p4. Yups, got it? Yes or no? So that means if I ask you how many unpaired electrons are there in sodium, unpaired means single electron in orbital. So I just have one unpaired electron in sodium. Rest all are paired. They are in pairs. How many unpaired electrons are there in sulfur? So we have 1 and 2 unpaired electrons which are single electron in an orbital. Yes. Yes, of course, KK Mishra. Done? Okay. Now let me write the configuration for iron. Iron, the atomic number, I hope you know. What is the atomic number of Fe? Iron, guys, can you please tell me the atomic number for iron? So the atomic number for iron is 26. So how our rule says 1s first, then 2s, then 2p, then 3s, then 3p, then 4s, our rule, and then we have 3d to be filled. So let me make the orbitals. 1s has 1 orbital, 2 has 1 orbital, 2p has 3 orbital, 3s has 1 orbital, 3p has 3 orbital, s 1 orbital, and now d we have. So how many orbitals in d? 5 orbital. 1, 2, 3, 4, 5. Degenerate. Yes, good. Now, how many electrons we are supposed to fill, guys? 26. Atomic number of iron is 26. Very good. Let us start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and then 26. So 4 unpaired electron, and the configuration of iron is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. If I ask you which is the valence shell of iron, the outermost shell, the shell which is at last, outermost shell, can you please tell me the outermost shell in iron? Yes, which is this is the configuration of iron, right? Can you please tell me the outermost shell? 4th shell, because this number, these 3, they represent the shell. Maximum value of shell is 4, guys. So 4th shell is the maximum shell, the valence shell. It's 4th. 1, 2, 3, 4. This way the shell will move. Got it, guys? Yes. Okay, let me tell you again here. One term. The species, be it atom, be it ion, be it molecule having unpaired electrons, they are known as paramagnetic species, right? So paramagnetic species are those which have unpaired electron, even if it is 1. Paramagnetic species means having unpaired electron. If all the electrons are paired, no unpaired electron, we call it diamagnetic species. What we call it? Diamagnetic species. Got it? Paramagnetic, unpaired electron. Diamagnetic means all electrons are paired. So it is how they behave with the external magnetic field, whether they attract it or repel it. Okay, let me ask you more examples. Potassium, atomic number is 19. Can you tell me the electronic configuration, and can you also tell me whether it is diamagnetic or paramagnetic? So once you are pro, you can directly write 1s2, 2s2, 2p6, 3s2, 3p6, because P has 3 orbitals. So maximum 6 electrons you can fill. S subshell has 1 orbital, maximum 2 electrons you can fill, right? So total electron has to be 19. 2 plus 2 plus 6, 10, 12, 18 and 19, right? So it has unpaired electron, that means 1 unpaired electron, that means it is paramagnetic. Got it? And how can we calculate the magnetic moment? This is magnetic moment. Magnetic represented by mu. Very important questions have been asked on this. Magnetic moment, the formula is under root of n plus 2. What is n, guys? N is the number of unpaired electron. What is n? N is number of unpaired electrons, right? So in this case, and the unit is Bohr magneton, Bm. So let me calculate the magnetic moment here. The number of unpaired electrons is 1. 1 plus 2, that is under root 3 Bohr magneton. Bm is the magnetic moment for potassium, right? N is the number of unpaired electron, magnetic moment. This is how you calculate the magnetic moment. Okay. Now let me ask you the configuration of ions, right? Suppose I have magnesium 2 positive ion. You know the atomic number of magnesium is 12. That means a neutral magnesium atom should have 12 electrons. Now as I have 2 positive charge, what does that mean? That means it is a cation. 2 electrons are removed from magnesium. That means how many electrons are there in this ion? 10. Out of 12, 2 are removed. Right, so I am supposed to fill 10 electrons. So what will be the configuration, guys? 1s, then 2s, then 2p. So 1s, 2 electron, 2s, 2 electron, 2p, 6. This is the configuration, guys, for magnesium 2 positive. Got it? Now let me take another example of anion, Cl negative. Cl negative, you know the atomic number of chlorine is 17. Now it is having a negative charge, that means it is having extra electrons, that means 18 electrons you are supposed to fill. So 1s, 2s, 2p, 3s and then 3p. Let's fill it. 1s2, 2s2, 2p6, 10 electrons, 12 electrons, 18 electrons, right? 1s2, 2s2, 2p6, 3s2, 3p6 I have. Got it, guys? I hope you get that, guys. I hope this is clear to all of you. Hi everyone. Hi Dharampal. Yep. Now, suppose I have Fe, again iron, and I told you the configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 3d6 and 4s2. This is the configuration. Now suppose I have to write the configuration of Fe2 positive. That means I have to remove 2 electrons. Now if you have to take out 2 electrons, they are removed from which shell? The valence, the outermost shell, guys. Though 3d is filled after 4s. While writing the configuration of Fe, we fill 4s electrons first, then we move on to 3d as per Aufbau or N plus L rule. But now if I am to take the 2 electrons out, so I will of course take them out from the valence shell. And 4th shell is the outermost, the last valence shell, right? That means I will remove these 2 electrons. So what will be the configuration of Fe2 positive ion? 1s2, 2s2, 2p6, 3s2, 3p6 and 3d6. So these 2 electrons from 4s are removed. So we will fill the electron first in 4s and remove also from the 4s. So very careful, because this is a mistake that usually students do, right? You are supposed to take out the electrons from the outermost shell, the valence shell first. Yes? Okay, great. Now let me tell you the exceptional cases, the configuration, the exceptional configuration. First is the case of chromium. Chromium has atomic number 24. So now as per rule, I am supposed to fill how many electrons? 24 electrons. Let me write the order in which the electrons are being filled, right? So 24 electrons, let me fill it. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. This should be the expected configuration. 4s will be filled first with the 2 electron and then 3d. 3d has 5 orbitals, so I will fill like this, right? But what happens here is, this is not the correct configuration, but what happened here is, this 4s electron goes here, right? That means the correct configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d5 and 4s1. The 4s electron goes to 3d. Now why this happen? Because it gives the symmetry, right? Because if it goes there, 3d also has 1 electron each and 4s. So nature loves symmetry. So symmetry is there, right? So this is the correct configuration for chromium, exceptional configuration. And second reason is exchange energy, because there is not much energy difference between 4s and 3d. So the electrons can exchange their position. So this electron can swap its position with this, right? With the same spin, of course, right? So they can exchange their position. Whenever the electrons exchange their position, they release energy and become more stable. So in this case, more exchanges are possible. This 1 electron can exchange with 5 electrons, right? So more number of exchanges means more release of energy, more is the stability. So because of this kind of configuration, which is half filled, we call it half filled. You can see D5 half filled, right? Each orbital has 1 electron. This is half filled configuration. So half filled or fully filled, in which the orbitals are completely filled, they are highly stable. Why half filled are stable? Because of symmetry and more exchange energy, which gives the stability. So that is why your chromium has this configuration, not this. So please keep in mind, note it down. Remember, the configuration of chromium is 3d5 4s1. Reason? Symmetry, half-filled configuration it is. See, this is 4s2, 3d4. One is left completely unfilled, right? So this is more symmetrical. There is not much energy difference between 4s and 3d. Right? So this is exceptional case chromium, and similarly we have exceptional case for copper also. Up to atomic number 30, copper atomic number is 29. So 29 electron, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and it has to be 3d9. This should be the configuration as per the rules, as we are doing in rest of the atoms. But again, can you see here? 4s is filled with 2 electrons and 3d has 9 electrons. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So 1, this is single. If this electron goes here from here, this becomes completely filled. So the configuration becomes 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d10. D becomes completely filled. So this is wrong and this is right configuration for copper. So just make sure, guys, you keep in mind these special exceptional cases for copper and chromium, and we do have reasons for them, guys. More symmetry, more stability because of more exchange energy, right? Yups. So copper and chromium, the special cases we have, right? So I hope now it is clear, guys, how to write the configuration. So you can see the configuration, the electrons filling in various atom, lithium, beryllium, depending upon their atomic number. Half filled and fully filled, very stable, extra stable. Half filled means each orbital of the subshell has single electron. Fully filled means each orbital has paired electron. Right? Copper and chromium, the special cases I have already told you, where the normal rules are not being followed. So please, you can see. And you know, helium is a noble gas, right? Helium is a noble gas, neon is a noble gas. There is a shortcut to write the configuration. Helium is a noble gas, neon is a noble gas. So we can write, say, lithium, I have to write the configuration. I can write in square bracket helium. That means it is same as that helium, and after that it is 2s1. So up to helium it is same, 1s2. But you can express that in terms of a nearest noble gas only, right? For example, for sodium, I can write neon. It is same till neon, then 3s1, because till neon it is 2p6. So that is a short way of writing in terms of a noble gas only, right? So the configuration you need to practice, and once you are done, guys. You can see the configurations, various configurations, the chromium, copper case, the exceptional cases. So you can see the argon, neon, right? And I have already told you cation formed by the loss of electron, anion formed by the gain of electrons. So you should also know how to write the configuration of ions. Let's have some questions for practice. Let's see how many of you can answer these questions quickly. Number of unpaired electron in D6 configuration. So you are supposed to fill 6 electrons in D subshell. How many unpaired electrons it will have? Quickly answer. So D subshell. How many orbitals? D subshell has 5 orbitals. And you are supposed to fill 6 electrons. So following Hund's rule, because they are degenerate. D subshell has 5 orbitals. Any D, 3D, 4D, 5D, they all will have 5 orbitals. So 1, 2, 3, 4, 5 and 6 electrons, because I need to fill 6 electrons. So how many unpaired electrons we have? 4 unpaired electrons. Got it? Yeah. The answer indeed is 4. Perfecto. Next question, guys. I hope you can write the configurations of these 2 electron H negative, negative charge, 1s2. Na positive means 10 electron, 1s2, 2s2, 2p6. O2 negative is also 10 electron, F negative is also 10 electrons, right? Okay, great. Now, please tell which is the ground state, that is the stable configuration for nitrogen. So, nitrogen, this is 1s. Which option is correct for the configuration of nitrogen, guys? This is 1s, this is 2s, and this is 2p. Yes, quickly, please. The correct electronic configuration for nitrogen. Which option is correct? Nitrogen atomic number is 7. Please follow the Hund's rule. P will have single electron first and that too parallel spin. Not like this, not like this. This is also correct. Right? Either this or this. Both A and D are correct. Either they all should spin down or spin up. A and D both are correct, bachcho. Right? Both are correct because they should be parallel, either all down or all up. Next rule. Which rule is not followed by the following configuration? If the electrons are filled like this, which rule is violated? Means which is not being followed here. Yes, please. Which rule is not being followed here, guys? Yes, the answer indeed is Pauli's exclusion principle, because if there are 2 electrons with the same spin in the same orbital, shell is same, subshell is same, orbital is same, and now the spin is also same. So of course the answer is it is not following the Pauli's exclusion principle. We cannot fill the 2 electrons with khopdi up, right? The same spin in the same orbital. Yes. Okay. Now the next question. The orbital with maximum energy. This type of question I was telling you that these type of questions are being asked. The orbital with maximum energy. N plus L rule. The one with N plus L rule, right? The one with maximum value of N plus L will have maximum energy. Yes, Nitish, please ask. Yes, you can ask. So the one, calculate N plus L value for all. For 3D, 5P, 4S, 6D, calculate N plus L value, guys. The one with the highest N plus L value. N value is 6. And L value, for D subshell, the L value is 2. So it is 8. Yes? Done? Okay, the next question, please. The correct electronic configuration and magnetic moment. Mu. For chromium 2 positive, remember chromium has exceptional configuration. So let's see how many of you can answer me. Write the chromium configuration and then take out the 2 electrons from it. Just take the 2 electrons from it. No configuration, just do it like for chromium, guys. Do it for chromium only. Right? Do it for chromium only, guys. Chromium 2 positive it is. So do it. Let's see. Chromium 2 positive. Is any configuration correct? Yes, waiting for your answer, guys. Oh. Yes, this is the configuration of, guys, chromium. The electronic configuration of chromium. This is the configuration of chromium, right? This is the configuration of chromium, not chromium 2 positive. So now if I have to write chromium 2 positive, the configuration is argon till argon, it is same. 3d5 4s1, right? Now I have to take out 2 electrons. One will go from 4s and then I have 3d4. That means 4 unpaired electron and the magnetic moment will be 4 point something, right? So this question is about chromium, not chromium 2 positive, but the configuration is about chromium, like the magnetic moment is for chromium 2 positive, right? So configuration you are supposed to tell for chromium and the magnetic moment you are supposed to tell for chromium 2 positive. Got it, guys? It's not the same for both. Okay, now this is INJ, so though you have seen the answer. So I request everyone to know these terms, though you will understand when you learn magnetism in physics for Junior Science Olympiad. What are diamagnetic, ferromagnetic, ferrimagnetic and anti-ferromagnetic? This is more of, I will say, this is there in your chemistry in CERT also. But in physics, in magnetism, you read these. So just make sure know the definition of each of them because it was asked in INJSO once, right? Now IJSO question. Quicklime is calcium oxide. Please, this is International Junior Science Olympiad, the last stage. Quicklime is CaO. That means calcium ion is there and oxide ion is there. And you are supposed to tell the configuration of cation and anion. Quickly, let's see. Aditri, you are supposed to read yourself after doing the magnetism. Yes, IJSO 2019 question. Let me know the answer, guys. Calcium, what is the configuration of calcium 2 positive? And what is the configuration of O2 negative? Calcium 2 positive has 18 electrons, O2 negative has 10 electrons. So what is the correct answer? Cation is calcium 2 positive and anion is O2 negative. Of course, the answer is, what is the answer, guys? A. 1s2, 2s2, 2p6, 3s2, 3p6, 18 electrons in calcium 2 positive and 10 electron in oxide. 1s2, 2s2, 2p6. This is IJSO previous year question. Now the homework question for all of you guys. Which of the following has maximum unpaired electron? More unpaired electron means more magnetic movement because magnetic movement formula is having n number of unpaired electron, right? Yes. Let me tell you a trick also. Suppose for any species they have given you the value of magnetic movement is 2.6. So the digit before decimal tells you the number of unpaired electron. That means the species has 2 unpaired electron. Suppose the magnetic movement for any species they give you is 4.3. That means how many unpaired electron is there? The digit before decimal. 4 unpaired electron is there, right? Yes. So anyways, this question is your homework question. You are supposed to tell the maximum number of unpaired electron here, guys. Yups. And again, I'm telling you guys, we have already launched NSEJS ranker batch to target NSEJS 2025. Daily sessions, live sessions are there. Tattva will be there. English batch, regular live class, test, mentorship, full on support to crack NSEJS is there. So make sure that if you are targeting NSEJS, have a proper disciplined preparation. The batch price is 5999 and the coupon code that you can use to get this price is NPR Pro. Link is there in the description box, guys. And do not forget to subscribe our new channel for Science Olympiad, that is Vedantu Science Olympiad. This is another channel, guys, not this channel. And very soon we are moving our this B2A series, which is specifically targeting NSEJS on that channel, right? So make sure you are a subscriber if you are a Science Olympiad aspirant. Okay, bye. Take care. God bless you all. Keep learning, keep growing, guys. See you in the next session.